AB Calculus 3.7, day number 1, the chain rule. What we're going to learn today in this video is the derivative of the composite function, also called the outside-inside rule. A repeated use of the chain rule will also come up. Okay, so why? Why do we use this? The chain rule is the most widely used differentiation rule in math. Okay, this operator, d dx, is like adding, square rooting, or some other operation. Okay, we're just performing the derivative with respect to x. It means to take the derivative with respect to x. So if we change x a little bit, how does the function or the y value also change? The derivative is a rate of change, a ratio of two changes. We always have to compare how something changes as something else does. So let's consider the derivative of this nasty function right here. This is x squared minus 3x plus 4 to the 60th power. Clearly we don't want to expand it. So how do we take that derivative? We need another rule. And the proof of the chain rule we're not going over in this video. However, if you're interested, Google it, YouTube, whatever, or ask questions. We can show you how that's done. Okay, so let's look at the schematic within the chain rule here. So if we take the derivative of f of g of x, we take the derivative of the outer function, leave the inner function alone, and then multiply by the derivative of the inner function. So what would the outer function be here? Well, it'd be this expression to the 60th power. So the derivative of the outer function would be 60 x squared minus 3x plus 4 to the 59th. That would be leaving the inner function alone. Then we would multiply that by the derivative of the inner function. So let's look at example 1 here. If I take the derivative with respect to x of this function, I'm going to call my inner function 2x plus 1 over 3x squared plus 2. My outer function is that to the 6th power. So if I were to leave the inner function alone, this would be 6 times 2x plus 1 over 3x squared plus 2 to the 5th power. Right, I use the power rule on the outer function, and now I'm going to multiply by the derivative of the inner function. To get the derivative of the inner function, I have to use the quotient rule. So we're going to take the lower function, 3x squared plus 2, times the derivative of the upper, which would be 2, minus the upper, 2x plus 1, times the derivative of the lower, which would be 6x. And then I'm going to divide that by the denominator, 3x squared plus 2, quantity squared. Okay, so I'm not going to try to simplify that much at all. Actually, I might just leave it right like that and kind of leave the rest to the imagination. To some extent, there might be instructions given within a specific question as to get it to, fully simplified form or something like that. Today, of course, like the other rules, I just want to solidify how to do the mechanics of this chain rule. Okay, so let's look at example 2. All right, so we're going to have multiple chain rules here, and let me explain why. So the outermost function is something, right? So sine of 5x to the negative 9th minus 8x squared to the 8th power. Okay, so I'm going to actually rewrite this as the derivative with respect to x of sine of 5x to the negative 9th minus 8x squared to the 8th power. Okay, so the derivative of that would be 8 times sine 5x to the negative 9th minus 8x squared to the 7th power. Now the next most inner function is sine of, and then the innermost function is 5x to the negative 9th minus 8x squared. Okay, so then I'm going to multiply by the derivative of sine, which is cosine, leaving the innermost function alone. You can see I'm trying to conserve some space so that I can now find the derivative of the innermost function, which would be negative 45x to the negative 10th minus 16x. Okay, so you can see how this is the derivative of sine of 5x to the negative 9th minus 8x squared, and then I use the chain rule to then work the remainder. So the derivative, I'm just going to rewrite, would be 8 sine to the 7th 5x to the negative 9th minus 8x squared. You don't have to do this. I'm just doing this to kind of clean it up because I have problems with not completing something to a certain standard. Okay, so that would be our derivative, and that, folks, is intentionally tedious so that you start to get used to the chain rule and its process. Typical problems do not require quite so much algebra. However, again, the mechanics are the important part. Okay, let's move on and look at the next example. Example 3, calculating derivatives at a point. So let h of x equal f of g of x. Use the values in the table to find h prime at 1 and h prime at 2. Before I can find either of those, I got to find h prime at x. Based on the chain rule, h prime at x would be f prime of g of x times g prime of x. That's the chain rule in its clearest form. Okay, so h prime at 1 would be f prime of g of 1 times g prime of 1. All right, so what's g of 1? Well, g of 1 is 2, so this would be f prime at 2, and g prime at 1 is 3. Okay, so f prime at 2 is 7. 7 times 3 tells us that h prime at 1 is 21. Okay, h prime at 2 will be f prime at times g of 2, or of g of 2, excuse me, times g prime of 2. H prime of 2, therefore, is f prime. G of 2 is 1, and g prime at 2 is 4. Since f prime at 1 is 5, then h prime at 2 is 20. Okay, let's continue on with an AP style question, non-calculator. F of x is cosine cubed 4x. Find f prime. Okay, so using the chain rule, I would get 3 cosine squared 4x times the derivative of cosine 4x, which is negative sine 4x times the derivative of 4x, which is 4. So if I clean that up, I get negative 12 cosine squared 4x sine of 4x. Yep, there it is. We get B. Okay. Ask questions, you guys, in class, or shoot your teacher a message if this isn't making sense. I'm starting to move at a quicker rate, but hang in there. You'll get it. Practice is good. Let's move on to the next example. Okay, another AP style question. For how many values of x will the lines tangent to the graph of that thing and that other thing have the same slope? So I'm going to call this y1. I'm going to call this y2. I want to know where y1 prime, is equal to y2 prime. Okay, so y1 prime, oh goodness. Looks like y1 prime is going to equal a little product rule work. So the derivative of the first would be 2x times e to the x plus the first times the derivative of the second, which is still e to the x, y2 prime, oops, not y squared, y2 prime will equal, derivative of the first is 1, so that'll be 1 e to the x plus x e to the x. So I want to know where those will be equal. So let's get some colors going here. There's y1 prime, there's y2 prime. Where are they equal? Okay, so let's do a little work here. That's 2x e to the x plus, I'm going to distribute, that'll be x squared e to the x plus 5/4 e to the x. Where is that? Equal to e to the x plus x e to the x. Alright, so we're going to combine some like terms. Alright, so these two will combine on the left side to be x e to the x. Alright, nothing will combine with x squared e to the x. And then if I subtract e to the x from 5/4 e to the x, I get e to the x over 4. So I want to know where that equals 0. Okay, so the first thing I would likely do is factor out an e to the x, and then rearrange. So I'm going to put the x squared first, and then I'm going to put the x second, I'm going to put the 1/4 third, set it equal to 0. Okay, so I'm going to have to do a little bit of work here, specifically factoring. So I'm going to factor. So this would be x plus a half squared. So if you foiled that, you'd get x squared plus x plus 1/4. Okay, so using the zero product property, e to the x would either have to equal 0 or x plus 1/2 would have to equal 0, right? Because I've got x plus 1/2 times x plus 1/2. So clearly e to the x will never equal 0, and x plus 1/2 will equal 0 when x equals -1/2. Now this is our only solution. Therefore, there would be one value for which the slope of y1 would be equal to the slope of y2. All right, let's continue with example 6. This will be our last example of the day, at least in this video. Let f be the function f of x equals the quantity 2x minus 1 to the 5th times x plus 1. Which of the following is an equation for the line tangent to the graph at x equals 1? Okay, so first I need to know this. I need to know a point. So that'll be x equals 1, and we need to figure out what f of 1 equals. So f of 1 will equal 2 times 1 minus 1, which is 1, to the 5th times 1 plus 1. So we'll get a 2. So we got a point. Now we need a slope. We need to know f prime at 1. And then we'll have a point and a slope, and we can plug that into our point-slope form, and it looks like we need to get it in slope-intercept form. So to find the slope, I need f prime at x, which is going to require both the chain rule and the product rule. So I'm going to use the product rule, but within that, the derivative of the first function will require the chain rule. So the derivative of the first function will be 5 2x minus 1 to the 4th times the derivative of the inside, which is 2. And then we leave the second function alone, plus the first function left alone times the derivative of the second, which is 1. All right, so f prime at x is equal to 10 2x minus 1 to the 4th x plus 1 plus 2x minus 1 to the 5th. All right, so if we plug in a 1, we're going to get 10 times 1 to the 4th, which will be 1, times 2, which is 1 plus 1, plus 2x minus 1 to the 5th. If x is 1, that'll be 1 to the 5th. Okay, most mistakes you guys are made with the little algebra issues. So this will be 20 plus 1, which is 21. So the slope will be 21. Looks like I can knock off C, D, and E because of the slopes. But I do need to do a little work to figure out whether or not we got A or B as our final answer. So y minus 2 is equal to slope x minus 1. All right, so that'll be y minus 2 is equal to 21x minus 21. So it looks like it's going to be B. As I add 2, that'll be 21x, combining like terms. I get minus 19. Answer is B, and that is it for the chain rule. Ask questions, shoot a message, go on YouTube, find your Find your weakness and break it down. All right, we'll see you in the next video.